good afternoon and welcome to Global SMT and Packaging Show at Productronica in Munich. My name is Viktoria Rawinski. I'm founder and CEO at Rawinski GmbH. And today I invite you to join me for an exciting panel discussion on topic high reliability. What does it really work to us? Electronics engineering is developing so much faster than any other industry. Today's innovations are already history tomorrow. And we are not just talking about new, more powerful technologies, components and materials for PCBs. We are also talking about high reliability. And all of these things bring progress, but also new challenges in terms of quality and reliability every day. Especially with high reliability products, it is essential to ensure that there are no deviations from the design, from the material selection, but also from the product specification. And today I would like to discuss with leading experts from the electronics manufacturing industry where they see challenges in manufacturing processes in their field and how they manage to keep pace with continuous international competition. And my first guest is Jörg Trödler. Jörg is a technical consultant in assembly and connection technology in electronics, from manufacturing concepts to the evaluation in additional materials and reliability under various conditions. He's also member of various national committees on electronics. Welcome, Jörg.
Welcome.
My next guest is Markus Hoffmann. He brings over 20 years in international experience in electronics manufacturing, including several years living and working in Hungary, China and United States. Wow. As a chief sales officer of the Swiss headquartered Verab Group, which operates 5 production cities across Europe, he leads new business development and M&A initiatives with a strong focus on high reliability, sectors such as defense and medical technology. Markus is passionate about bringing cultures and shaping geopolitical perspectives within our industry, while aligning advanced technology and quality to drive sustainable growth in an increasingly competitive market. Welcome, Markus.
Thank you for having me.
My next guest is Dr. Olaf Schönfeld. Mr. Schönfeld is a European sales manager at Cestron, the market leader for cleanless solutions for electrical assemblies. Mr. Schönfeld successfully drives the market introduction and distribution of products and services that ensure the reliability of electronic assemblies. And in recent years, many of his customer projects have dealt with the reliability of HV applications in electromobility and charging stations. Welcome, Mr. Schönfeld. Thank you for being my guests today for an exciting panel discussion on the topic of reliability. And my first question is, high reliability is an important and highly topical issue that is driving the electronics industry actually right now. But we can always find the right balance between reliability and cost. I'm not sure. Just according to the motto, you get what you pay for. What do you think on this topic?
Shall I start? Maybe I can. I had a similar discussion a couple of weeks before because I said when you have a look to the, for example, solar industry, there was mentioned that the benchmark for techniques and for quality is Germany. Unfortunately, due to the cost effects, it is moving out of, went from Germany, and we have a similar discussion also with power electronics, with standard electronics, etc. pp. I believe we have really a we have some high reliable products, and we have a high reliability. In some cases, I believe that we have more than that, because to be sure that it survived 30 years instead of 15 years and so on, and there's really a big designs about most and more reliability, and it can touch the PCBs, the alloys, the technology. Don't forget the discussion about voids and solder joints, exactly a big discussion, and we haven't seen it until there was some X-ray machines on the market and there was no voids, and now we have voids. So that means the major method is that you have really to make a right balance in between reliability and cost. So an over-driving or an over-engineering just for reliability, it is maybe then bad for the economic questions. You need that what you need for reliability, and there are some good test methods, and that is what we need also for the European market and globally.
I love your point of view over engineering, because on the one hand you have over engineering, on the other hand you have cost driven decisions, and I think we have to find the balance. Markus?
Definitely true. So I fully agree with you on that statement. Maybe I can add also the perspective of an EMS company on that, because we are working with the designs and with the ideas of our customers every day. And what we can see is that especially in our markets, in the healthcare and in the military application, in the end of the day, if you save 5% in costs, that still could cost you all your product line in the end of the day. So in my opinion, it's not a question about reliability, yes or no, it is a must. So every product has a product specification, and in the end of the day, it needs to fulfill, like you just mentioned, what it's made for. We in Verab, we believe that there is always no black and white decision on that. So what we need to do, in my opinion, is really take a look at the function, take a look at the environment this application works in, and then make a proper decision. And this decision should not be, as you mentioned, over-engineered, because what we especially see in Germany or in the European market is that we're thinking about solutions, and solutions, we never bring it to the markets. Time to market is a critical factor, but in the end of the day, time to market should not push us in a direction to forget about the quality. And this is something we need to combine. It's difficult, it's not easy, but we need to do that. Otherwise, competition from outside the European Union or from the European continent will do that job for us. So we need to be straightforward, should not forget about the total environment, but always keep the goal, a product on the market in mind.
So this is a good point, and I also agree with both of your opinions. Let me add something. I think it's very important when we talk about reliability, what area we are addressing. So what is the application? The next thing is, when we go for aero defense application, it's totally different from the requirements than when we go into, let's say, consumer application or even an industrial application. So it really depends on what is the environment, what are the conditions. And I think when we in Europe want to be ahead still of a lot of these product developments, it's important that we develop standards and drive standards forward, which enable us to make reliable products which are good enough, and not one piece more, just that they fit exactly what is needed. And in addition, that we try to make this reliability more smarter. So at the moment we involve a lot of cost. We have to bring the cost down by developing smarter tools and processes, especially during the validation phase, to be faster and to come faster to a reliable product that at the end can be produced to the right cost, which meets the market demands. And this is, in my opinion, where we could improve, but on the other side we did already a lot of these things, especially when it comes to new areas like e-mobility. But now I think also when it comes to mobile robotics, we have still to reconsider, are we using the right standards and the right requirements? And then I think it will be much more easier for us in the future to stay ahead.
But do you think we need standardization just on the European level, or is this something we need to do on the worldwide level? My keyword is raw material, for example. You have also to make some standards for raw materials as well as also for the manufacturing processes and even for the final product. Depends on the application.
Yeah. So actually both. So of course we should work in Europe on standardizations, and but of course we have to align also globally and also bring this kind of view into the market. And at the end it will be a competition between the different regions, and but also I believe that these standardizations will help the industry also to meet the right demands.
Yeah, fully agree. The thing I would like to add on that is that I'm always a fan of something like, it's called design for region as well. So again, if you have a product which needs to follow up the same specific quality regulations globally, then you need to have that standards also based on the raw materials. Otherwise you're ending up in a mess. Like again, an EMS company who has several sites around the globe, if you don't have the same standard everywhere, how you could judge the quality? So it's difficult on that. But on the other side, if you have products which have, let's say, certain local specifications, then I think you should overcome this, this intention to always standardize everything the same everywhere around the globe, but going into details. Let's see what the local market are demanding, also checking what is the expectations there, and then go into a direction to have a design inclusive the raw material for the specific region. So that's something I think in certain areas is also important to follow up.
Just a short comment by the end. All those products that were produced outside of Europe coming to Europe, and then they have to fulfill, for example, the European standards. So that means it is like going to the school. What is the benchmark? The benchmark maybe is the highest level benchmark, yeah, and then it is. But on the other hand, we have to thinking about the production cost, and I cannot understand that we have, for example, a qualification, and we are just changing the alloy, for example. Then we have 10 other devices with that alloy that we will change, also the new alloy that we will change, and here we have everything is qualified, but we have here just a changing, and it costs 300,000 euros. Yeah. And that makes no sense when you have similars already on the market and is approved, etc. pp. Why should you do that? So that is a point that should be easier.
What I see from my daily work on material analysis is that customers face some quality issues when their supplier, for example, just substitute one filler within the solder mask without giving the customer any information, and they don't adjust the manufacturing processing parameters, and the product will get electromigration, non-polymerization, or not completely chemical, fully completely chemical reacted components, and the customer has no idea.
Yeah, but that is a no-go. That is generally a no-go. That is not discussable when that is a relationship in between the customers and the supplier, and that is a no-go.
But do you think this is something which can be solved by standardization? Can we also do some standardization for the processes when you change any part of your process? If you substitute your suppliers, you have to inform. When I look at high reliability, it's really a serious topic.
I'm wondering a little bit because there is a relationship in between supplier and customer, and there is maybe a standardization as a contract. And it is contract. I know that such contracts, and there's written down every changes has to be mentioned. It can happen because the raw material is empty or whatever. It can happen, but that has to have in the contract in between the supplier and the customer, from my point of view.
Yeah.
Maybe we can have a standard for automotive or whatever, and we cannot write it down, but that is for me typically normal that it has to do.
Yeah, there has to be agreement between customer and supplier, and they have to agree individually also for the different projects what is really good enough and what is acceptable. In many cases, the customer would like to make the requirements as strong as possible in order to avoid any risk. That will increase the cost. On the other side, the supplier wants to have less efforts as possible, what also is then decreasing the cost. So they have to meet somewhere where the overall target of reliability is met in a way that we can say this product is not critical. And that is ongoing discussion, and it is not like you close it once and then you don't start it again. It's a continuous process, and with more and more experience in the industry, the requirements will also becoming less and less, but still good enough to achieve the reliability you would like to have. Yeah, it's also a matter of experience. When you go into a new field, first you don't want to take a risk at all. Later, when you decrease that, you are able to meet requirements which are still good enough to make sure nothing is happening in the field. And this is where it should go, in my opinion. Yeah.
And also for the audience and for you, let me add one statement I always try to tell our sales guys, but also our purchasing team. Communicate clearly and openly and early enough. Early bad news or good news. So if there is an allocation out there in the market, if there is a shortage of a certain raw material, talk about that. Never try to hide it. Never try to think, it will not go wrong. It's anyhow just that one batch, and afterwards everything will be fine. So don't play tricks. So we are an AMS company. We don't have own products. So our let's say image out there is our quality standards. And if we once fail with that, the market will know. So we definitely need to communicate early enough, clearly enough. And I would not agree, it's not that you said that, but there is people out there that say, no, I'm strictly following the rules and the regulations, I don't look left and right. That's wrong. Always look left and right, but talk with your customer, talk with your supplier. Try to find a solution. Often enough, you can open up the tolerances, or you can open up the alternative materials. Let us think back the time when there was a COVID and the allocation. So at that time, automotive, we don't do automotive, but automotive had really, really high standards everywhere. But the raw material was in shortage. So out of a sudden, few things were allowed to do. And it worked. But only if you talk openly. If you try to hide something, that's the worst thing you can do.
That's a very, very good point. I hope that a lot of suppliers are watching this panel discussion.
Hopefully, and I'm always believing in the good faith of people. I think it's not a bad faith from the companies that they try to trick you, at least the companies I know. But sometimes, let's say, the focus is not good enough. And sometimes also they don't know the consequences which could occur if they try to find a shortcut. So always educate your team and be open and clearly.
And in addition, create data. So when you want to convince your customer that with less efforts you can achieve the same goal, then prove it by data and show them and give them the right the arguments so that they can accept it. No one will accept something just by someone says, no, we can do it. No, you have to prove it. And now it comes how you prove it. So we need the right test methods and the right analytics in order to create these kind of data. Also to give the appropriate interpretation of these data, and then convince by these kind of reports also the customers that it is not a higher risk to relax specific topics in the specification. Yeah.
I absolutely agree. The worst sentences is by our experience. It is the worst sentences.
That's great, yes. Open communication, And
data.
Data, proven data.
Yeah.
And more understanding from the supplier side, of also from the customer side.
Yeah.
How can we ensure that products designed for high reliability applications also really work reliable just by testing, or do we have more tools, specifications, more control of processes, more control of whatever?
Should I start? The problem is, not the problem is that we have mostly and we have to have an order to find results in 4 months or 5 months or 6 months. We cannot really guarantee the 15 years for working time. For example, the automotive industry. There are some correlations in between, and we are working on test specifications and test methods to see in a short time really the long time. And in the end, we have to compare it. For example, the automotive industry has one problem. We are testing it, for example, the TCT from -40 to +150 degrees C. We are seeing the results. We have limits, shear stress, whatever. By 50% reduction is allowed, not more. But we haven't seen really the results after 12 years, 15 years from the streets. The devices doesn't come back, and we cannot really compare it, and it makes it a little hard. But I take now the words by the experience of the producer. They have really some also some data.
And also the lifetime
modules, etc.
Yeah.
that they can really see that. The only point what I would like to address is also, is it in some cases overdressed? Yeah, that is a question that we have really to discuss. But okay, there are some specifications, some data on the market and possible to get. Yeah, and that is, from my point of view, I think good enough at the moment.
Yeah.
Yeah, and on top of that, the question is always, you already mentioned it, Viktoria, how stable and how good are the processes. So a process validation on top of that, that's an important step, and also in the sub-supply chain. So in my opinion, sometimes we do not see what's ongoing on the sub-supply chain. So this is something which is not so much under control oftenly. So what typically, if you have a contract, let's say a quality agreement with your customer, it's you, it's him, and it's your sub-supply chain. But the sub-supply chain, so the guys behind that, this is often not proven. And I know from your experience, we talked about that often in the past, that is sometimes issues occur and nobody really knows where this is coming from. And then you start thinking and you have a guess, and guessing is always not good. I always say hoping and believing is for Sunday church, but not for business. So processes validation is a key, and also audit your sub-supply chain, find common solution with them, and take something not for granted automatically, just it works for the couple of the last years.
So don't work blind.
Yeah, exactly. And feedback loops. Maybe let me add that as well. So I had a customer once who bought back all his old machines and brought it to a specific place, and they checked it from first to the last screw. Why? Because they wanted to create a feedback loop. A feedback loop, how is this system looking like after 15 years? What was the problem? Is it good in shape or not? Not just to optimize the optimization and the after sales, but really see how we can influence the design of future systems.
Yeah, and I think one topic is also you need to live this reliability approach along the whole supply chain. So, of course, you have incoming inspection, but incoming inspection of components or even specifications of components does not give you, when you are in the assembly industry, always the right safety, let's say. So at the end, as you mentioned, there will be audits also on your suppliers, and it has to be a kind of agreement about what is the right level of product specification you would like to get into your own supply chain. Yeah, and that requires, and it depends really on the application. We don't do it for everything. We only do it for very critical, sensitive things, like for instance in the EV industry, when it goes to technical cleanliness, you need to think about how you manage the particle load at your suppliers, because you don't want to get these particles into your own factory. And that is something where you need to give also these suppliers the right tools that they can make it smart enough. It doesn't make sense to overload them with a lot of testing, because then they have the cost on their side. And when every supplier is doing it, then we are adding up more cost and cost everywhere. So we have to find smart methodologies in order to really keep the cost down but achieve the target. Yeah, and this is where I think we need, and we are still doing a lot of little improvements here and there in order to bring the cost down. Yeah, and working on these test improvements is also something what I would call had a lot of innovations the last 3, 4, 5 years to make it smarter, to make it with less effort, but achieves the same goal. And then also the balance between cost and reliability is much more easier to fulfill. Yeah.
So we need to find the balance. But do you think AI is something which maybe can help to ensure the quality of sub-supplier with very intelligent way?
Yeah. The problem is with AI, you need to feed it with data. So, but when you are starting in a new applications, new things, the data are not there. So we need to think about it. For instance, sometimes, especially we are working in this big field of failure mechanisms and how to avoid them. But when you see new failure mechanisms, exactly, especially which came up now with the introduction of high voltage application like in the electromobility. New failure mechanisms need to be seen first and then to be learned and understood, and then you can feed AI to find it out maybe automatically. But at the moment we don't see in this field that there is much where AI can already help us. Yeah.
And you need the right interpretation.
Oh yes,
Yeah.
that's a great point, yes.
So here I don't see AI, but when it comes to standard, very mature processes, of course AI can do a difference.
Markus, what do you think?
I really don't like that we use the word AI so inflational. So, because everything is nowadays AI. But of course, let's say learning models linked to AI can help us to increase quality and also, let's say, increase reliability. I give you one example out of our production fab. Beside electronics and cable, we also do inductive goods, and we do inductive goods for the military sector. And this product in the, let's say, 5 years backwards was 5,000-6,000 pieces a year. So you had a lady there sitting doing outgoing inspection, visual inspection. Of course, also electrical tests, but visual inspection was one of the most important factors there. During the fact that the volumes go up dramatically, we thought about, okay, what we can do. Should we hire more ladies? Should we do it in a second shift? But we thought, no, let's do a little bit more in this direction you mentioned. So we integrated the camera system, which we started to do the outgoing inspection over the camera system. Did it work? No. But then, why? Exactly what you said, you need to have the data. Of course, if you start, you do try and error, and it didn't look so well. But then we created data, we created backgrounds, we did a little bit of learning in that. And I cannot say too much, but today we are on a level that we didn't solve failures not detected from the camera system in the data for the last 2 months. Of course, still, as this is military application, this person is still cross-checking, because it would be a little bit too tricky to fully rely on that immediately. But again, the last 2 months in the ramp up, we didn't saw any not detected failures yet. So it's not always, in my opinion, the big solutions, the big super new ideas, but we should do a little bit more baby steps into the right direction. I think that's better to wait for the perfect final solution, in my opinion. But that's not valid for every sector. This is what you said before. Other sectors, this might be the total wrong approach. So always keep it in a way to be flexible on how you approach it.
And we have a lot of embedded PCBs. You cannot see that and detect that. We have some special components where the connect and there are other components and you cannot see and inspect it just by electrical measurement. But a failure can be inside when you have a cold solder joint, for example. You measure it as good and it isn't. And so on and so on. It is not so easy, but I believe the most important point is really that when you have a good AI, you need in the very first beginning, in the very first stage, also a good interpretation.
Yeah.
But to have a very, very good quality of raw data.
Yeah.
And then do one step after another. Smaller steps, more smaller steps than one large step.
Yeah.
Right?
So, yeah, it's a long way still for AI to replace these kind of activities, but who knows what will happen in 10 years. Yeah.
I have a good example. We are writing now a standard for X-ray machines, for X-ray inspection, what is the void level, etc. pp. We are writing it down now and we bring it also as an international standard. And what we are doing is when you have a new product, you couldn't take an automatic inspection systems at the first stage. You have to control it by eyes. Also what you can see in the X-ray. But you have to do it by eyes, and then to compare the production level, that is easy. Then it is okay when you have the white pictures inside. But in the very first stage, you have to control it by your eyes.
Yeah.
But AI doesn't replace the human factor. There's a natural intelligence cannot
correct.
be replaced.
Yeah, it's correct, but
At least not now. I mean, or maybe not in the next years. But as I said, I mean, AI is also developing. Maybe we will get surprised by new algorithms which can do much more than they can do today. But this is open. Yeah.
And this is an example we made an water Robin test with different X-ray machines, and we got really different results.
Yeah.
But if I think about the field of Marcus and just think about AI makes decision for very high reliability areas, I'm curious, do you think it ever will be possible?
Never say never. So again, we are all, I think, close to the market, close to technology. Even us, maybe 5 years ago, would not have expected what's ongoing nowadays. So I would say never, but I agree with you today. 2025, November, here in Munich, I'm not finally seeing it yet. But that doesn't mean that it never comes.
Okay, we are running out of time. Thank you so much for being here, for being my guests today, and for this really exciting discussion. Thank you.
Thank you.
Okay,
Thank you for having us.
Why do something 3 times when you can do it only once? Using N1 Pass technology, BTU's new Profile Tracer is a next-generation thermal profiling tool, providing real-time data acquisition for oven optimization. It identifies inconsistencies due to temperature variables at both the product level and the heat source. Profile Tracer measures dual temperature locations as well as vibration, all in one pass, giving you time to attend the more important things in life.